Hello and welcome to the Decode Rev 1.18. My name is Daniel Stanfill, process engineer from Aurora Boardworks.
And I'm Elias Malfavon with Metal Etch Services.
Sean Kincaid with KNF Electronics.
And our guest tonight is Tony Kelbert. He is a mechanical engineer from Venice, Florida. He's known for his eclectic posts on LinkedIn, ranging from GPS tracked rubber duckies to in-depth FEA of ceiling hooks, and perhaps even more famous for being able to eat a Chipotle burrito without dropping any. Tony, thanks for joining us. Usually we start by asking what a person's background is, but I think the more pressing question for everyone listening and watching is just going to be, what is it that you actually do for your day job?
No one knows. That's hilarious. So I am a mechanical engineer. My day job is with a company here in Sarasota. We're a design firm. So we work on everything from like industrial composters all the way up to hypercars. So I, can't say names specifically, but you would recognize them if I sold them. Said it. Most of our work is with transportation products, but we do stuff with medical products as well. So the range of experience I've had there in the last 3 years, as opposed to my previous 12, whatever the heck it is, it's been unreal. I've been on the widest variety of projects I've ever been on in my entire life. So as mechanical engineering, we usually take things up through the prototype phase and then, hand it back to the customer for full production, but we can see it through production as well. Yeah, it's been probably the most fun job I've had in my entire career because it's just so diverse.
Awesome. And for the listening audience who can't see what we're seeing, it looks like you've got quite the proto setup behind you. I can see at least 2, maybe 3 3D printers there. So I'm imagining those aren't part and parcel of your day job. So maybe tell us about some of the proto work you're doing in your little lab there.
So what we have here, this is Prison Mike. This is Bamboo X1C. This is Big Tuna in the corner. And then Dwigs, obviously named after characters from The Office, but they run basically mass customized products that I've been selling for the last month or two. We've shipped about 200 so far from them. Wow. Usually they're running just round the clock. I think this little guy I got about 2 months ago, he's got 1,500 hours on it. And then these two over here, I got about 3 weeks ago, and they've each got about 200 on a piece.
Then you built a custom rack, right? I saw a post where you got your fancy setup for all the different reels so it can keep feeding itself pretty continuously, right?
Yeah, and I updated that too recently. So these guys are just hanging on posts right now, and then the Bowden tube comes in from the front. And that's kind of cool because usually you've got the filament mounted on the back, but it's a real pain when you're in a tight area like this. So I just moved the filament to the forward side and then ran it down through the Bowden tube through the back. Makes it a lot easier to change over.
What are the custom parts you're building?
I can't say. Top secret? Yep, it's top secret.
That's actually that's a challenging thing about custom circuit board stuff too, is like, Sean, how often can you actually broadcast who the customer is that you have or what product that your boards are going into? Most of the time we're not allowed to say, right? Like,
I don't have many NDAs, so I'm not like you.
Okay. Okay.
But I mean, I don't go out and brag about it, right? Like, I'm old school, so we don't.
Yeah.
You just don't talk about it. You don't. It'd be classless to go around showing silk screens and and talk about what it actually is. There's I mean, because it's legal. It's legal. It's clear. Like, hey, don't talk about this, right? So you can't argue if you do, right? Like, it's you sign the paper. So I mean, I get it, but most of my stuff, I don't. We've had customers for 20 plus, 30 plus years, so it's kind of generational stuff. We're
just a mutual respect there that keeps people from opening their mouths. Yeah. And that makes sense.
So Tony, I think my knowledge of you has all come off your LinkedIn posts, and in the open, Daniel kind of touched on the fact that they're eclectic. There's a wide range of topics, and some of them are humorous, some of them are very engineering based. My question to you is, how do you come up with this? Is this like, are you sitting down and putting together a hard strategy, or is it kind of Leroyed out where it's just whatever's on your mind that day you're running forward with? Talk to us a little bit about what goes on in Tony's head and how you come up with these topics.
Yeah, for sure. No, I can't say if they're Leroyed out. I've never heard that phrase before, but I can say that I do not have a strategy at all. Like, this is top of mind, what I've been thinking about. Like, that's just kind of typing my inner monologue, if you want to put it that way. So when I think about something, I know a couple of other people that I've talked to are like this too, but I'll get an idea and I'll phrase it 17 different ways in my head over and over and over again. And then it just kind of spills out, you know? So most of the stuff that I've written, that's like gotten a lot of notice, I spent about 5 minutes on, like, just as long as it took to type it out and hit enter. And a lot of times, like, I end up going back in and editing stuff because I'm like, oh crap, I totally misspelled that word, or that doesn't make any sense, because it's literal brain dump. And then whatever, and we let it sail. So that's kind of how it works. And that's been interesting because honestly, like, LinkedIn for me started as a pure creative outlet. Like, I just, so I'll tell you the story of how I got started on LinkedIn. And it was about 7 years ago. I was looking at my car and there was this like little goofy clip in the upper corner of like where the window comes up. I was like, I have no idea what that is. I don't know how to ask the question to Google it. I've never posted on LinkedIn before, but I like really want to do that. And then I didn't do it for like 6 years because I think the problem with LinkedIn is like everybody sees what you post, and including the people that you work with. So many people are disincentivized to post anything because the people that they work with are going to see it. And if their identity is something other than what they want to use to make their living, then there's that clash. And it's just like, nope, I don't say things that don't follow the company line. And that's fine. I was in that boat for a very long time, but then I started like, you know what, whatever. I'm just going for it, you know? And that's kind of how that gathered momentum. And it's cool because now I have a group of people that I can ask a question like, what's that stupid clip in the upper corner? And somebody told me, I don't remember what they told me. Dang it. No, I think it's like a gasket routine so that the gasket doesn't like curl under and the window goes up and crushes it. But that's cool. And it's cool to be able to have those conversations with a wide background of people. And that was kind of my whole goal on LinkedIn, is just talk to a lot of people I find interesting. So there's no end game here.
I know that's certainly happened with my earbuds, like posted about earbuds not working and boom, get them x-rayed on a CT scanner machine and get all these cool images of, just because had somebody in the network who wanted to do that,
Yeah, that's sweet. So did you mail them to Littlefield? Yeah, cool.
Yeah.
That's interesting. I saw those pictures and I couldn't figure out what the heck was going on with them still, but it's probably because I don't know how to read a CT scan. But
I couldn't either.
Did you get a final diagnosis? Was it like battery swelling or something? Or
okay. I guess there's no way to like say with 100% certainty, but when you looked at the batteries inside of them, you could definitely tell they were like extremely damaged. So it was very likely the culprit.
Okay, gotcha. That makes sense. Yeah. What do they call those on Reddit? The spicy pillows, like the batteries that blow up. And
you hit on something I think all of us have definitely noticed, that sometimes it feels like there's a inverse relationship to amount of effort put into the post and how much traction it gets, right? Like, sometimes all of us have spent, like, you work on it like it's almost like a white paper or like a real article that's going to be published in some sort of technical publication or something. It's like 74 impressions and you're like,
it's giant waste of time.
Post a picture of a sunset and it gets like 5,000. It's like, how did this?
And I think it's like, it's mixed too, right? Like, I really don't care how many people engage on a post because I mean, whatever. That's fine. But but also I think people like just kind of like the, hey, I'm just talking to somebody that's doing something kind of perspective where, I don't know, if you want to read a white paper, there are millions of those you can go find somewhere. But I think the key thing that, I like about what all you guys do there is it's like, it's technical stuff, but it's coming from a human. And I think that's really important. It's a way to make more technical things accessible to a wider group of people because
Sean
they're
does
like,
use
oh,
Chat GPT a lot, but for the most part, it's coming from humans. Yeah.
hey, whatever. So I tried to do something and it worked miserably. So I've been working with this company called Dister, and it's basically like AI engineering tools for um, AI engineering tools for engineers, AI tools for engineering. But I had it ingest all of my posts and then write like me, and it was a train wreck. It didn't come out sounding anything like me. It's awesome for engineering, but I don't know. Maybe I hated it because it wasn't a thought coming out of my head. It was like being regurgitated to me in my voice. I think that was probably the actual problem. It did a great job of emulating me.
We can't all be Luke Matthews, I guess. I don't know if you've seen his posts, but he's I think it's him anyway. Somebody in that ilk has talked about using AI using their own posts to train AI so that the language sounds like their own. But
Yeah.
I could never do that. I don't know.
Nah. No, that's no fun.
Yeah.
But, yes.
Sean, you looked like you had something to say a second ago. You want to fire a question off?
It's
Yeah.
I was just gonna say with Sora coming out with ChatGPT, I'm like, it's gonna, like you talked about the human element posting. I tried it out. I finally was able to, because there's been like a wait list to sign up, and I finally got in tonight at like 7:30 to sign up for it.
Really?
I had to run like 3 videos for me, and I mean, I'm on the plus version, so I only get like 480 to 720p, and it's like a 10-second clip. But what I asked it to do, it didn't do it at all. It wasn't giving like the vision that I wanted to do. And don't get me wrong, I've only submitted 4 videos, right? Like 4 prompts, but what I was seeing, I just I mean, you see on TV or online, they're like, show me a woolly mammoth in the desert, right? And it's like this beautiful scenery and it looks great. And I'm like, show me a circuit board getting melted and the gold refined from it, right? And it showed the opposite. It actually showed gold pouring onto a circuit board and then turned the circuit board gold. And I was like, okay, we're not there, right? We're not.
So what's crazy about that, and it's something that I've noticed too, is like my expectations for ChatGPT and AI tools were like way up here when I first started, and then I'm like, oh crap, these kind of suck. And then now I'm kind of like coming up that, what do they call that? Falling off the Mount Stupid into the slope of enlightenment or whatever, and the Dunning-Kruger effect thing. But I think that's kind of like how everybody's working through it, because like with an AI tool, like AI tools are just big collections of data. It's like a Martian that read everything that was ever written, but has no idea what it is to exist in the world.
Right.
And so like when you give it a prompt, it's like, okay, I'm going to find the first thing that I recognize, and then I'm going to go build a score around how well what I make matches that prompt. But if it doesn't start looking in the right spot, it can go just completely haywire. You have to give it so much context. Like, okay, you're an engineer looking to answer a question about a beam. All right, that gets me there. And it's kind of like an address on a piece of mail. Like, I'm going to the United States, I'm going to Nebraska, I'm going to Omaha, and then I'm going to this address. And then you can get good results. But if you're like, hey, I just want to go to 235 Front Street, it has no idea what to do, and it just spits out nonsense. But
that's a great explanation.
Yeah, I would say Sora felt like, I don't know if you remember ChatGPT 3 when it came out. It would hallucinate on you and just go random, doesn't make sense. And that's kind of like how I felt using it today. Was like, this is very very. I mean, the first one I had to try doing because I've always wanted to visualize a circuit board going through a reflow oven, but nobody can get a camera
to
because it's so hot in there. It's like what is it, like 250 degrees Celsius or something like that. So no one can visually see it happen. So I was like, let me see if Sora can create it, and then it created. I wish I saved it. I deleted it, but it was like a box. It didn't even go through like a conveyor oven. It was just floating around in the middle of air going like this, and you couldn't see the heat. You couldn't see the joint solder. You couldn't see anything. It felt like a hallucination, right? Like it's like that's not, it's anti-gravity reflow was like what it was showing. There was no rails, there was no nothing. It was just floating in the middle of air and heat, kind of it was weird. Yeah.
Well,
new pattern.
I wonder if part of the problem is because there's not actually a lot of training data on this stuff.
Maybe.
Like there aren't tons of pictures on the internet of inside of a reflow oven because nobody can get a camera in there.
Yeah.
So it just sort of like takes a swag and
I'm gonna try too the $200 version. Like right now, I do the $20 ChatGPT Pro Plus. But I'm gonna try the $200 version just to see what I can get out of it, right? Because
might as well.
I use it to help me actually coding. Kind of built my entire web program at work, helping it repeat code for me. I'd set up the template and say, hey, repeat these columns. These are the columns I want. And then, the typing speed on the thing is unbelievable. So if, you're looking for encoding, right? Like that thing can speed up a lot. And then obviously it's going to spit out stuff where you have to know what you're looking for. And like, there's not an SQL state for that, right? Like, please don't call that, right? Like, so you have to you have to like, what you're doing, but I could see it.
I think that's kind of it. Like humans are the bumpers on the bowling alley there, and it requires a lot of feedback.
Yeah.
Does Fister do anything with image processing at all, or image creation, or it's purely text driven?
No, it's text driven, and then it can generate like graphs and like Bodhi plots and things like that. Like
tables.
It's very good at that, but as far as graphic processing, no, it's not. That's not what it's meant for. But
sure.
It can, however, tell you. I wrote a program that ingested the wind speed data from St. Petersburg International Airport because the rubber duck story, like next phase of the rubber duck story is mount that rubber duck on a weather balloon and send it to the stratosphere with a GoPro attached.
Nice.
Can you start with the first phase and pretend no one's ever heard of it and tell people what your rubber ducky experiment was?
Yeah. So there's a weird part. It was actually, so I'll just start from the beginning and we'll edit out the parts that don't fit because there's kind of a weird part. So a while back, I had this weird idea that I was going to track the behavior of a chaotic system by dropping multiple GPS trackers very close to one another in the ocean. And what I thought would happen, it kind of came from the book Moby Duck. So there was a shipping container that crashed somewhere in the Pacific on the way from China. And then I forget how many thousand rubber bath toys floated out. And they found these like all over the world, like most of them ended up in Alaska. But then there were some that like went all the way around to the East Coast somehow. And I'm like, but hold on. They were all dropped out of the same, 8 by whatever area. How the heck? But just all those tiny little random interactions eventually led them in very disparate, directions, which is kind of interesting. Like, I think it's an interesting metaphor to extend to people too. Because like people you go to high school with, some of them are just like all over the place, but for all intents and purposes, maybe had similar upbringings, But I wanted to track that in a repeatable way. So I got this company, Land Air Sea, to send me 5 GPS trackers and then licensing for a month to track them. But the problem is, they operated on cell towers. So I could only go a couple miles offshore. So
once you get too far out, you lose the signal. And
hold on a sec. So I put them in these. This is a bottle of Yoo-Hoo, and because I figured it would float, and then I 3D printed this capsule on the bottom, and then the GPS tracker went in here. I had to break it to get it out, but it's a little souvenir. But anyway, I had Daisy, Donald, Huey, Dewey, and Louie. That's what I named them. And then I just chucked them in the ocean and let them float around for a while. And what ended up happening is they washed up on shore immediately and people took them home.
Oh no.
So it was chaos, but not the chaos I was expecting to record.
Did you go and
Now,
get
was that
them?
on the
kind of
Gulf?
interesting. What's that?
Was that on the Gulf side or the Atlantic side?
Yeah, Gulf side of
Okay.
Florida. So one lives in like. Anyway, people took them home. One of them got to Minnesota. Like somebody was visiting and put it in their bag
Wow.
and took it up to Minnesota. I was
Wow.
like, dude, I can see where you're at. Like, so he offered to throw it in the Mississippi and see if it got down there, and it just went, and it went right on shore, and now it lives under the Hennepin Avenue Bridge in Minneapolis. Like, there's no way of knowing where it's going to end. Anyway, so I tried it a couple of different ways, and it just didn't really work because the problem is like with a system like that, there's always going to be drag on the low, on the shallow areas. So the center of the flow will flow relatively quickly, but that means that any big objects are going to get pushed off to the side pretty quickly. And when I look at the GPS data, that's exactly what happened. Like on the Gulf, it floated out a little ways and then it just went, and it went right on shore. And of course, people picked them up. And so that didn't really work. So I realized what I needed to do was get these into a chaotic system that was like controlled a little bit. So my plan was to, the duck Jeep thing where like if you have a Jeep, people set the little rubber ducks on the hood, whatever. So I got in touch with the founder of that movement and I was like, hey, I've got this little rubber duck. Hold up. I got this little guy and he's got a GPS tracker in the bottom. So will you take him around with you for the summer to all the Jeep events and like build kind of an Instagram following for him and a Facebook following for him? And then we'll just release him out into the wild and be like, hey, I'm Louie and I'm Off-Road Louie. That was going to be his name, right? Mm-hmm. And he was going to hitchhike around the United States until I stopped paying for the tracking service and we were going to see where he ended up. It would be fun. But unfortunately, before we got that to launch, Allison actually, so Allison Parliament was her name, but she passed away very unexpectedly, just out of nowhere. So that never got launched, and kind of out of respect for her, I was like, that's over. We're not doing that. So, yeah, she was a wonderful person too, and she was really into the idea, but it just, that didn't happen. But so then after that, back to the duck experiment, what I realized is that, first of all, I needed a tracker that didn't depend on cell towers. So I found a company called Mimiq.io, MIMIQ.io. And basically they use long range wide area network signaling that's based, that's satellite based. So you can get, tracking around the world. And what they sell their product for is tracking containers on container vessels and, making sure that the containers are moving to the right spot and things like that. So I partnered with them and I was like, hey, send me a tracker. I'd love to put it in one of these ducks and send it out. But how the heck am I going to get it offshore far enough? And I don't have my own boat, so I'm dependent on rides offshore. So I was like, you know what? Let's attach this dude to a hot air balloon, send him up into the stratosphere, let it drop wherever he drops, and that will track him. That's evolving. So next phase actually is take 5 of these on a hot air balloon. Not, this one will be on a duck and he'll have a GoPro attached and all that fun stuff. The other 5 will just be just in little PCB boxes, basically. And those are the ones I'll track. But this guy is going to fly on a guided parachute back to land. So he'll have a GPS guide on his parachute and it'll be controlled. So he'll be able to do a controlled glide all the way back. But in order to do that, I got to know where he's going to land. And so that's what I use Dister for. I just ingested all of the high altitude wind speed data into Dister over a period of time. And that did the calculations like, okay, if this dude's floating at the exact same rate as the wind, how far offshore does he get? And then what I was hoping would develop is like a little landing zone where like typically the wind speed's going to, be this. He's going to end up, but I started it during a hurricane. Like that's when I started tracking the data. So mixed results there, but it's been going for a couple of months. So I'll check in and I'll, see where he ends, see where the target landing zone is. But anyway,
so
that's
you say that
rubber duck.
The simulation's been going for a couple of months, or the duck's out there now?
No. I've got the simulation going, trying to narrow down that target area. Because my hypothesis is like when a cold front's coming in, there's going to be a lot of onshore wind. So I could probably release him then and then go pick him up in Fort Lauderdale. But when there's no cold front going through, he's going to end up 50 miles out in the Gulf, and I've got no way to retrieve him. Like I don't want to hit that sweet spot of, maybe I can land him in like Mayaca City or the Everglades or something and actually go get him. Yeah,
That's awesome.
Well,
yeah,
you said the word PCB, and so that's the glue. That's the glue that got all of us together in the first place. So one of the things we were thinking of doing on this episode was to have you kind of turn the tables and ask us some questions from the mind of inquisitive nature. So do you have anything related to stencils or board fabrication or anything like that you were curious about?
So many. So going around, this is my understanding of it, and please correct me. But Sean, you're the PCB guy, so you're building up the boards. After Elias, you're doing the stencils, so that's gonna provide like all of the traces. Sean would take that, generate it into a PC board, and then Daniel, at Aurora, you guys are machine gunning those parts onto the prefabricated boards. Do I have that right, or am I way up? What's
Some
the
of it?
Oh, Sean's shaking his head, all disappointed.
Go ahead, Sean. You start them off.
Yes.
After the circuit board is fabbed, that's when Elias would then go and do what he does for Daniel, is where then he makes a stencil where you apply paste to it. And then that paste gets deposited onto the circuit board, and then he puts the parts onto it. So, yeah.
And Sean started out in board fabrication. Now he does assembly also.
Okay.
But for a long time, he did the board fabrication. So he has more expertise there, but he's been doing assembly for a few years now. Right, Sean?
Yeah.
Okay. That makes a lot of sense. So if you're not doing assembly, what is PCB? Like before you were doing assembly, what does it mean to fabricate a PC board?
So picture basically you have a copper foil, and then you have woven fiberglass, right? And then you have another copper foil on top of it, right? And then from there, that's like your base material. You'll drill your holes, or you'll expose your component, like where the component lands in it, and then then you plate it up. Then you strip out all the copper you don't want on that foil, and then you put the colors onto it. If you want green, purple, red, right? Any lettering if you want on it. Then you put, if you want it to be gold finished, or if you wanted it to be lead finished or tin finished. And then you test it, and then at the very end you have a 18 by 24 inch block of as many circuit boards as you can fit onto that panel, and then you route them out into the individual little pieces that you get.
Okay.
And then, but that's just blank.
Help me under.
That's just blank. There's no parts put on it yet. There's nothing like that.
Okay, so you've got this 18 by 24, you said, panel of. Are the traces on there yet, or is it simply copper, fiberglass, copper coating?
Yeah, I don't know how to detail, because usually when I people ask how do you make circuit boards, right? And they're always like, you mean like the things in the computers, right? Like kind of just you even ask about traces is like I could probably count. I don't know if I've ever have anybody even go further, right? So thank you for that. Right?
Of course.
Basically, you have your copper foil, and then you put this blue film on it called resist, right? And this blue film then goes into a room, right? And all of this is light sensitive. There can be no white light. It has to be yellow light. And it goes into this room, and on from this room, most people today use a laser exposing machine, and it'll literally shine light where you want your traces to go. And then from there, in where you want your holes and where you want your pads to be, any place that you want copper to stay. And then you run it through this developer, and this film is actually photo imageable, right? So anything that didn't have light to it washes away. So then from there, then you have like an outline of just basically blue with copper removed where you wanted it to be.
Okay.
Yeah.
So, all right, that makes sense.
That's
so
for
you've got you.
that's for like a single side. If you do double side, it'd be the opposite, right? Because you want the copper to be exposed. So it's kind of
Okay.
flip flop for double side, but for single side, that's how it would go.
Well, my understanding of it was that you'd have a base board and then your stencil. That's how you get your traces on. But it sounds like that's not the case. Is that
No. So
okay?
so where my
That's how
product comes
thick
in.
film works.
Okay.
We can get to that in a second.
So where my product comes in is kind of at the beginning of Daniel's job, right? So you've got the finished PCB, and it has these exposed metal areas where the components are going to be mounted onto the surface of the board. And in order to create that mechanical and electrical connection, you need a medium to accomplish that, and it's solder paste, right? So
Yeah.
the stencil is patterned to match the individual circuit board with openings wherever those metal pads are. And then solder paste is printed through the stencil. And then Daniel or Sean are going to take their components and place them precisely on those areas. So the stencil is a mask or a stencil that is used to deposit solder paste through and locate paste in very specific locations on the circuit board. And then that paste will have components placed on it and then be reflowed and hardened. So that creates not only a mechanical connection, but the electrical connection onto the bare circuit board.
Okay. That's starting to make a lot of sense then. So, so you get the traces from Rashawn, and then you build the stencil to put the glue on, and then Daniel comes back in and sticks the components on, reflow it, weld it all, or solder it all together. Okay, that makes sense. I think I saw a video that one of you posted the other day about how those stencils are used, and that is kind of wild. Like going through the machine where it just wipes the solder onto the board. That's pretty cool. And how do you get it clean? Like I would, whenever I use a stencil, it always bleeds underneath. So how do you even solve that? Is there like massive amount of pressure in the wiper, or is it a property of the paste? Okay.
The stencil and the board, like there can't be a gap there. You need them contacting each other, seated nicely. And that's kind of where Elias's expertise comes into play in the strategy for the design, because it's called gasketing, having a good seal around all of the apertures onto the pads. So if the openings in your stencil aren't the right size or shape, or they don't align properly with the pads, then you won't have proper gasketing, and then the paste will bleed under and get onto the underside of the stencil and onto other areas of the board and cause bridging or excess solder balls or whatever, all kinds of problems, and also potentially even continue to mess up future boards if you don't clean it in between. But so generally, when you have good gasketing, you don't actually have that issue.
So that brings up a question that I wanted to ask, because I've only ever seen like pristine board that works 100% of the time. But what does a defect look like? Like, I know there are defects. What do they look like? Is it just solder bleeds out underneath and gets all weird? Is Sean
we'll show a bunch of them on the screen, because like it gives Paul something to do. So one of them would be a bridge. And so that happens a lot when either you have too big of apertures, or they're too close together, or you don't have proper gasketing. And so you'll have too much solder in between the pads. So it'll actually allow a connection all the way between two pads, and it'll bridge them all together and cause a short. And so that's one problem that happens. Another would be a tombstone, which is where one side reflows faster than the other side. And so the side that reflows first actually hardens. And while the other side is still liquid, it pulls the component up. And so the side hardens and pulls it up, and while the other side is still liquid. And then it hardens with part of the component suspended in the air, and it doesn't even maintain its connection. Yeah.
Okay. So weird question for you. Well, not weird question, normal question. So how do you find that in QC? Like, obviously it wouldn't work if I plugged it into my computer or something's going to go horribly wrong, but you don't plug it
Sean?
into a computer every time you do a QC check. So how do you do that? Are you just connecting connectivity between, or checking connectivity between points, or what does QC look like in that process?
But Sean, you got all the fancy equipment there.
Well, for me, we have a 3D AOI, and
Okay.
it is based.
An AOI is a automated optical inspection.
Yeah.
Okay.
So it's basically like a certified master trainer in IPC standards. So like the gold standard for what to look for.
Okay.
And we can run it through there and it will flag for any IPC violations that it sees. And so, say the pad's right here and you're supposed to be connected flat to each other. If one of the parts is lifted up like this a little bit where it's not fully connecting, it'll detect that in the AOI, right? You can see it with a microscope or sometimes, but the AOI will check a lot of that. And then, so you're kind of flat, you're running all these boards through the AOI, and then you're hand inspecting any of the errors to see if they truly are errors or not.
And Tony, even a board that has like 1,000 placements on it would still only take like 30 seconds to inspect. It's crazy.
That was my next question. Like, what's the cycle time? Because I look at a board, I'm like, holy cow, there's a lot going on.
So fast.
Yeah.
That's crazy.
Yeah.
And
But
it's purely optical? Like,
well, it's 5 cameras and there's different colored cameras. Daniel was in the demo lab more recent than me. He might know let me know if I'm messing this up because I don't want to butcher Omron stuff. But the way it was taught to me was there's different colors shined on it. Red, blue, and I forget the other color. I don't know if there's another color.
They have RGB and CYMK or whatever that other range. They have like every spectrum of light on there to really and from angled sides to they capture everything. There's no shadowing. It's crazy. Like,
you might it's still weird to me because you're using light to inspect something that's main function is to conduct electricity. It's like building a part and then knocking on it to see if it sounds right. Like that's wild to me.
Sure.
And it's kind of cool that you can find defects optically and that quickly. That's
and not just
surprising.
Like Tony, it literally saves an image of a 3D image that you can zoom in, zoom out, rotate 360 degrees around, and see.
No way.
Yeah, it's insane. And then like that's saved into the server. So if you ever wanted to pull that back up, right? Or say you fixed it and then ran it back through, it could show you a before and after of what it will look like before you repaired it and after you repaired it. It's insane.
And so is it like serialized then where you can be like board ABCD 1, 2, 3 on 1211?
Yep.
Wow, that's wild.
Yep.
So your server is just getting loaded up with.
Well, it depends, right? Like, so the customer has to pay for that. And typically, the only people that I've had do that, it's one of those NDA type of things, right? And the way it worked was they were like full on, I want to come in and I want you to store my stuff on a separate hard drive and I'm going to take the hard drive away from you when you're done with this job. And so like nothing is on the server, right? It just went straight.
Wow, that's wild.
Yeah, all the files went straight to them and then that's it. Like it's like it never happened in my shop. It was nuts. Yeah.
And it's crazy to me too, because like obviously I'm outside of this world. So to me, a PCB is just like this thing that channels electricity correctly. But like it's kind of wild to hear you talk about all the NDAs and things around that, because it's like that's proprietary. That's valuable information on how that's routed. And as a mechanical engineer, that doesn't even cross my mind. It's just, well, we got to get the electrons to go to the right spot.
Yeah,
it sucks not being able to talk about everything. Like there's one project right now I want to talk about so bad because it's so it seems like revolutionary and groundbreaking and could do all kinds of stuff. But the only way I'll ever be able to talk about it is if it hits the market and becomes public knowledge. But
I got one right now that's really cool and it's in the market and the guy still doesn't want me to talk about it because he doesn't want his competitors to buy it near it. Like
Yep.
It's like, I feel you.
Yeah.
The circuit
You're like,
board
but do you
isn't
know what
that-
this would do on LinkedIn? Come on, help me out.
the circuit board isn't that proprietary. It's really, for me, it's the schematic, right? So you need
And
the
the bill of
schematic to understand
materials.
how it's going to work, but also you need, like Dana just said, the bill of materials. What components get placed onto where, right? Because, and also too, some of my good customers, they put like these Bluetooth chips on here that they program at their own place. So you could
Okay.
remake this entire board, but if you don't have the software that goes into it, you're not doing
Yep.
it with it, right? So
Yeah, or if you've got a BGA on there that's pinned out a certain way, like no one's going to be able to know how you programmed that thing just from an image of a board. You know, that's where
Oh yeah.
I feel safe posting some pictures of stuff as long as I make sure not to include the customer's name on the silk or
Yep.
too much information on there. But realistically, even with the populated component, like even with the board fully populated, you don't know what values those capacitors are. You don't know how much resistance is in some of those. If they're if they don't have an ID of their the resistance on there, you don't know what those parts are, and you can't like. There's a million variants of all those parts. Like you're never going to be able to just trial and error until you stumble upon the right design.
Yeah.
Image
Yeah.
alone will never get you there. Like
Yeah. That's
I think
really interesting.
your intuition was kind of leading you towards something that does exist, Tony, in terms of testing. And beyond AOI, there are instances where function testing comes into play, right? So in circuit testing, there are applications where prove it works, right? That happens.
Right.
So I think that's kind of what you were getting at. And
for one
that,
of our
that does happen.
customers, we actually have their finished assembly. Like we have the entire housing and the whole unit that it would eventually go in, and you actually have to put every board in and hook it up to all the different things and make sure it manages the boot up and that it does all the functions before you can actually ship it out. So
and let any of the magic smoke out before it comes out. And
that's right.
The coolest functional test we got, the guy that designed it built it so you can plug it in, and there's two light bulbs, a green light bulb and a red light bulb, and they're big, right? They're like this tall.
Yeah.
They're not your average light bulb. And then like you plug it in and it's clear as day, green or red, right? Like, yeah.
I feel like Tony would appreciate that any machine is a smoke machine if run properly, right?
if you run it wrongly enough.
Yeah.
That's my favorite thing is any blank is a blank. If you blank, that's like my favorite thing. Anyway, a buddy of mine just went on for like ages of all of the different.
Sure.
Anyway. Yeah, no, that's really cool. So then, Elias, I'm really curious because like stencils, those aren't big parts, right? Like, so you laser cutting this stuff or like?
Yeah, exactly. Laser
what's
cutting
the resolution on that?
It's pretty amazing how precise these machines are. I mean, they're repeatable. Yeah,
What?
exactly. Micron level accuracy.
Seriously?
Because some of the openings we're making are, 80, 90 microns. They're tiny. So yeah, they're
okay.
What's the size of an aperture for a 008, 004 component, Elias? Off the top of your head now.
It's in that 90, 95 micron range. It's small.
95 microns. So I don't really have a good concept of how big that is right now. Like I don't work in microns. I work in thousandths of an inch at the most. So
call it 4 thou. It's just under 4 mils. Yeah.
Okay.
It's
wow.
Small.
Yeah, that's tiny. And so then how is that controlled? Like I'm picturing something like, a 3D printer with a gantry going back and forth and moving a laser and stuff. Is that?
It's not
really
that dissimilar. It's gantry motion. It moves in the XY, and the laser is mounted onto the gantry, and the material's fixed, and it just flies over the top of the surface of the stainless steel at pretty breakneck speed.
You'd have a blast at his facility if you ever got to hang out for a day, Tony, and see one of these things get made. It's pretty sweet.
I might have to do that sometime. That sounds really interesting because that would be I don't know. That's fascinating. Like these things here, I mean, they're impressive, but if you turn them up to a ludicrous speed, I think is the top end. I mean, they start to shimmy pretty good, and you do get a little layer misalignments. They're very impressive, but I just can't imagine, like, how heavy is that head? Is there a significant amount of mass in the laser, or is it just tiny in there?
So the laser platform itself is extremely stable. It's heavy. It's granite based, and
Okay.
it's approaching 2 tons, right?
Okay.
But the actual laser head and gantry is fairly light. It's carbon fiber, so it's
Okay.
very structurally stable, but it moves quickly, and
Yeah.
we can produce upwards of 40,000 openings in an hour. So it's moving pretty quick. But it's like anything else, not dissimilar to those 3D printers that are behind you. And there's a
Yeah.
trade-off, right? If you go too fast on certain features, you're going to sacrifice some quality. So there is a balance to be had.
Yep.
You don't want to move too quickly for what it is that you're trying to do. When you're trying to really achieve ultra precise openings and they're very small, you've got to temper the speed back a bit. But they're fascinating to watch.
Yeah, no kidding. I really want to do that sometime. Like when Daniel was describing to me how the pick and place just machine guns this stuff onto the board. I think it was 30,000 components an hour or something like that.
So that's the rated speed of the machines that both Sean and I have. When I
Yeah.
went to Apex, the fastest one I saw, the machine is probably 3 feet wide and 5 feet deep, and it did 200,000 components an hour supposedly. So if you
So what does
stack
that
those,
sound like?
I don't even know. It wasn't placing when I was there. But I had to take their word for it. But
Yeah.
the speeds are always like, so ours is rated at 30. I think
Yeah.
the fastest I've actually ever seen in real time, because
Whoa.
the rated speed is an unrealistic situation that you would never experience in the real. It's not
Right.
feasible or realistic to what production environment actually is,
Yeah.
but I think the fastest I've seen is right around 22,000.
Geez.
I
So
think
30,000 is all 1 ohm resistors all in a line and just hammering
I
them
think
out.
it's 24
Okay.
actually, Daniel. I'm pretty sure it's not 30.
But still, that's
There's IPC, there's not IP, there's the machine rating, and then there's the challenge board rating. There's the 24 might be the rated speed that they got. Maybe it is an IPC challenge board, but there's a there's a standardized board that every manufacturer uses, and they have to populate the whole thing. And so
yeah.
that rating is a better, more accurate rating to what the machine's true performance is going to be. And so that's probably where the 24 is.
That's kind of funny you mentioned that, because that's something I was going to ask too. Like, is there a benchmarking board? Because like 3D printing, you got Benchy, and then CNC machining, there really isn't one. But what I've seen used before is like this guy here, and it kind of tries out several different features. We're just not going to say what it is because I'm going to get it wrong because I forgot. But it's
Sure.
it's a very early test of machining capabilities for apprentice machinists.
Sure.
And that was always kind of, when I was deeper in CNC, I really wanted to develop the Benchy for CNC, for automated CNC, because I thought it would be really cool to have a single part that could prove out like how deep can an undercut go and all of these different things and still get decent tolerances, which I still think would be pretty cool. But it actually would take a fair amount of development to build a part like that, and just a good benchmark. And it wouldn't look like as cool as this little fella does either,
Is that a pretty universally accepted benchmark, that little tugboat there?
Oh yeah, this is Benchy. Actually, there was a whole big deal. Like the first Benchy was given to the CEO of Bamboo Labs by whatever his name is. I don't remember. But yeah, like every person with 3D printers has at least 15 of these lying around, because it lets you, like, I'll hold it up to the camera as close as I can. This one came out pretty good, but you can see
a lot of different features.
A lot of different features and a lot of different overhangs. So like there's no support on a Benchy, so it tests like how far can your layers get over without the filament drooping, and stringing out and stuff. And then the curve of the bow, and there are a lot of different features that I actually don't really know what they're testing. I just know, hey, if you can get them a good one of these, that means your printer is calibrated well enough to make most anything.
What's the minimum change? What's the minimum size change you can make in the X or Y on one of those?
Beats me. I have no idea.
You don't know? Huh?
No idea. Yeah. I mean, you can kind of see like, well, you can't see because it's, so if you scratch it, you can kind of get a good feel for like how far apart the different layers are. And I don't know if that approaches the limit, but it, I can't say a number because I'm going to be just miles off. I know that.
Because like, for example, we bought a long time ago, we got like this super cheap one just to try to prove a concept.
Mhm.
And unfortunately it didn't work because the minimum change you could make was a tenth of an inch. And so like if you made something that was too tight and you made the minimum change, now it's too loose. And so you didn't
it just
have
looks like you made it with Legos kind of.
yeah, almost. It's like it was barely too tight. So, okay, let's make the minimum change we can to add a little, to add just a little more play. Now it's got way too much wiggle. Now it doesn't hold the board at all. And so it's kind of, but also
useless.
The one we had also didn't have a chamber. It didn't have an enclosed area when it printed in. So we learned very quickly humidity changes and temperature changes and all those kind of things are going to drastically impact the quality of the print.
Yeah, especially if you want to get the kind of higher resolution stuff, like that's going to really be your lunch on quality for sure. But actually, that's another question I had for you guys is I heard something the other day about flexible PCBs being used. I know almost like wiring. Like there was an application that I saw where it was it's on a vehicle. You turn the wheel back and forth, and there are signals going from the vehicle to the rest of the chassis. So you send that signal to one side of this. Like you remember in the 90s, there were like dynos or gyros on bikes where you pull the brakes and it was you could spin the handlebars all the way around. It's not exactly like that, but it's a clock spring. So it's like the ribbon cable wraps around a core, and then you can turn the wheel, and it just kind of cinches up the how tight the clock spring is wound. It's not an actual clock spring; it's just a ribbon cable. But I'm curious about your experience with those too, and do you have experience with those? And what do you look out for on like reliability and stuff like that on something like that?
They're all rated to specific flex.
Okay.
Before you run the risk of breaking the traces inside of them.
Okay.
For the most part, picture what you could get away with a piece of paper. That's pretty much how thin they are. So, however far you can bend a piece of paper before you start to get a crease, that's kind of what the limit I would take it to.
So is there a fatigue limit in conjunction with that too? Like if you're wiggling it back and forth,
Yes, they are. There's certain circuits that the flexibility is rated to a certain, like a light switch like a light bulb that may have a certain number of, rated to turn on so many times or whatever would be a similar type of thing where a flex circuit will have a number of expected uses. I mean, if you just stressed it nonstop back and forth, like eventually that's, even if it's within the acceptable range of motion for that flex circuit, it will still eventually cause repetitions. Yeah.
Okay. Yeah. Interesting. Yeah. I suppose it's still a metal inside there. It has a fatigue limit, and you're going to exceed it and get cracking. And so when that fails, I assume it's just like kind of intermittent signal transmission that is the result, or I guess I don't really know how they fail.
A trace broke. So instead of signal,
so just no signal.
You got signal, right? And then now there's no signal, right? Or power, right?
But in a certain position, that connection could be reestablished, right?
Right.
So I
and
think
that's why
that
I'm kind of wondering, like, it seems like when electrical stuff goes bad, it doesn't just do you the service of like dying and staying dead. It dies, and then it gives you this false hope that it was an anomaly and it'll come back.
Like my charging cord.
Yeah, exactly. Or the fan on my wife's van. Anyway, air conditioning is important here in Florida, and every now and then it'll just stop completely. But if you press the button enough times, it'll come back, you know, and I hate it. I would rather it just died and stay dead because then I would just fix it. But anyway,
That
Yeah.
sounds like a switch issue right there.
probably, yeah, probably. But let's
Sean,
see.
did you have a 3D printer question you wanted to ask?
Yeah. What's your favorite 3D printer and why?
This guy, Prism Mike, he's the best. So it's Bamboo Labs X1C. It's the first one I ever got. And also it's kind of there's kind of an interesting story.
How many
About it.
Those
versions?
aren't expensive either, but they perform pretty awesome, right? That's the
Yeah, they're about
yeah.
$1,000. I mean,
How many versions are they up from the one that Prison Mike?
I think X1C is still the flagship.
Okay.
And then I got two P1Ps over here. So this guy over here, this is rated for engineering plastics. I would show you a spool, but they all look the same. I like ABS and stuff. So it's got the heated in an enclosed chamber. So you can use engineering grade plastics because it maintains the heat and it sticks to the plate. If you don't have the enclosed chamber, it cools too quickly and then it starts to peel up and turn into a taco before it prints the remainder of the layers, and you get a lot of defects. These guys over here, these are just my production workhorses. That's the P1P. It's good for a polylactic PLA. I believe it's polylactic acid. I don't really know. But anyway, that you don't need as high of a temperature and it still maintains adhesion to the build plate. And so the product comes out well enough. These are about half price, which is why I have two of them, because they're just running production. So this guy over here is more expensive, but it's more capable.
We got lucky during COVID. Not my county, but the county next to me. We kind of help each other out, and they had this thing called Project Diamond. It actually just got renewed by the governor this week. And what they offered back then was you get a Mark Forge 2, and you just had to enroll in this program for $50 a month for a year. And so we were like, yeah, especially because back then the Mark Forge was like 10 grand, I want to say.
Yeah.
There was so much money, and it was so funny. I heard later on
600's a little easier to swallow than that.
Yeah, well, I was hearing later on too that like they weren't selling, so they came up with this in with the government, right? Like they pushed this thing because it was the terms were like, hey, if we ever need you to make PPE equipment or PP whatever it was, right?
Yeah,
you're going to be hooked up to the network, and we're going to run it through there. And if you've ever 3D printed anything, to 3D print a mask, you know how long that's going to take, right? Like, come on,
no,
dude,
it's
we're
not practical. Come on.
You got thousands of people, right? You're going to have billions of these things running all the time, right?
Yeah.
But yeah, that was a sweet deal. But the Mark Forge, but within this last year, all I hear is bamboo, bamboo, bamboo.
Yeah. And that's interesting too, because like, so I love bamboo in terms of performance, but I have my reservations about it in terms of data security. It has a LAN only mode, but everything goes through the cloud service. And so like I can sit in my living room and it's awesome because I can slice the part, I can send it to the printer, but it sends it through the cloud. So who's to say there's not somebody sitting there siphoning things off? Like that's a risk, and I would never use this for a.
You're going to see all your stuff on Temu all of a sudden.
Yeah. Yep. So I would never use them for producing a part that's like proprietary or anything like that. But the stuff that I'm doing is just mass customization. There's nothing really sensitive about it. But yeah, that's my only reservation about them. Performance wise, they're phenomenal. Yeah. So what I'm working my way up to actually is a wall of these. I don't know when it'll happen.
Wall of Prison mics?
Yeah, wall of Prison mics. The whole
That's
cell
terrifying.
block, and then it'll be tended by a robot warden. That's the goal. I have a connection that has that set up. It's a wall of X1Cs. They're running production constantly. The robot goes, grabs the plate, sets it on the rack, comes back, and and continues that. And I'd like to do that. It's just a fairly significant investment. I'm
You
not
don't
ready
have to
for
like
right now.
glue down the bed or wash the glue off or anything like that.
So, yeah, it depends on material. Like there's still a human in the loop somewhat because you got to have somebody to pop supports off and pop them off plates and ship them and stuff. There's minimal maintenance, but the advantage is it can just run 24/7 and it just keeps creating a stockpile. I have an idea, and if anyone wants to steal it, like you're welcome to do so because I think it would just be cool to have. But like conveyor belt on the bed, so it finishes, and then there's a line in the G code that says, "Okay, spit this thing out," and then the bed would just roll forward and it would drop off into a trough or a box or whatever, and
I
just
think we
keep
know
going.
somebody who could help with that.
Yeah.
Yeah.
She's listening too.
I see. Okay, cool. Steal that idea, please, and then
She
sell it back to me. I'd
she
even
probably
buy it.
already has something. I don't know if you've seen, but she
Yeah.
literally had her Thanksgiving dinner conveyorized to her family, and they just off and then
Because why not?
like a choo-choo train too, just keep coming with
I
different.
hope it ran through a reflow oven to cook the turkey too. Like
That's a
in
great
there.
idea. That's Cathy Rinne to give her the shout
Oh
out.
yeah. Yep.
Yeah. Flex line.
Yep. Cool. Cool.
Well, Tony, unless if you have anything else super pressing for us, like we don't want to take up too much of your time. We are extremely grateful that you were willing to join us and have fun for a little while.
Yeah, absolutely. It was a blast. That's cool. And Elias, if the offer stands, I will definitely be headed out your way one of these days. I'm very curious about that.
And anytime, man. We've got no shortage of burritos, and the weather's pretty similar. So
Fantastic. Awesome. Well, yeah.
did you want to take a moment to
That's
let our
right.
listeners know how they can keep track of your work, where they can find you, and just kind of plug
And-
yourself a little bit here?
If you have
Sure.
any new, exciting things you wanted to share with the public,
Yeah. No, I'm just kidding. So I'm starting my own podcast, which is going to be kind of cool. It's basically like the podcast that I'm starting is doing basically what I did here today, like playing dumb guy to your smart guy, like just asking questions because I think it's really interesting. I think there's a lot of interesting stuff going on in manufacturing that gets overlooked because it's not accessible unless you have a certain amount of pre-existing knowledge. It's like PC boards, like I said, I don't know anything about them. They're just boxes that go in my computer and make it work. And that's even as a fairly technical person. But I think, what you guys are doing with Decode is fantastic because you're making that accessible to a broad range of people. And I kind of want to do the same thing on the mechanical manufacturing side of things. And the first episode is actually going to be with Nabil Alana, the CEO at Dister, just to explain a little bit about, how AI works and what these tools actually do, what the applications might be for engineering. And really looking forward to that. We'll be finishing that up shortly. So yeah, glad to join you. Thanks very much.
Hey, what's your cast called, and where can our listeners find it?
So podcast is called Into the Weeds. The idea being, ask an easy question and then you let the expert go off into the weeds and come back with some interesting insight. I really want to make a t-shirt that's like this guy chasing a butterfly of an idea. He goes into the weeds and there's like the Calvin and Hobbes exclamation points, and then he comes out like pulling an elephant. Because that's what I feel like happens most of the time. Like you start with this dumb question and then all of a sudden, well, I talked for 20 minutes about this stupid rubber duck, like there's interesting stuff going on there. And I think it'd be interesting to bring some of that up, into the public eye. Yeah.
I like the duck story. That was cool.
Yeah.
I just wish
Lou's a good guy.
I want you to consider this though. I know you got your heart set on the balloon and everything, but I would love a rocket launch that thing, dude. Just straight up.
Yeah. So the problem with that is like when you start getting into designing,
he's thought about this already.
Yeah. So this is actually a pretty heavy payload for a rocket. So you need a significant volume of fuel to get it 50 miles offshore. And then when you start getting significant amounts of rocket fuel and then looking into guidance systems, you get on all kinds of lists that I don't want to be on. So I figured I'd easy way. Yeah, no.
Dude, you should just go right after Elon Musk, like they're about to launch, and just run on the Starlink and slap it on there, right? Yeah.
Well, I'm planning to go see New Glenn when it takes off, so I'll just put a magnet on there.
I want you to do that where you're filming, you're doing this big announcement, like you're filming your launch special, but it's like your tiny little one, but the real one's going off behind it in the background. And you just kind of play off of theirs. And it's just a whole proportion perspective thing where you don't know which pocket you're actually showing.
Like when they do the heart for the sun.
Yeah. That'd be so funny. My kids made a model rocket. And so part of what I want to do, actually, like I'm talking to a bunch of engineers at Blue Origin right now because I'm really curious about like what goes into manufacturing a rocket.
It'd be so cool to tour a place like that.
Oh my gosh, I know. That'd be awesome. But I've got friends in robotics, and I think I'll take my kid's model rocket, which is what I was trying to get up there, and have a robot grab it, and then just go like,
Yeah. Yeah.
Anyway, yeah, that'd be awesome.
Okay. Well, Tony, thanks again. This was a lot of fun.
Yeah.
I hope the listening audience enjoyed this rev.
Yeah.
I don't know exactly how to forecast the next episode because we don't really know what we're doing yet. So can't wait for the future. Hopefully you join us. Thanks again. And until next time.
Yeah.
Thank you, Tony.
Good. Thanks a lot.